What's good, YouTube? It's your boy Andre King coming at you today, and we've got a pretty good video, or at least the concept is great today. So we gotta, of course, deliver on the execution. But as you can see here from the title, PVST or Per-VLAN Spanning Tree versus Rapid PVST Convergent, and we're in the Eve NG environment. And this is one of those videos where whatever problem creeps up or comes up, we're just gonna work right through it. No cuts, no edits. It's learning mode today. And like I said, if you're labbing along with us on the left side, we're going to actually configure each of these devices. High level overview of this design or topology in case you're listening and walking on a path. Appreciate your support. What we have here is just two switches. We call it a distro switch 01 and access switch 01 as well. Between the two of these switches, we're going to configure trunk links on gig 0, 0, and gig 0, 1. And then on the access switch, there's a Windows PC that's emulated there on gig 0, 2. And so if you've been around long enough, you know, for me, we actually are going to be using my favorite tool, MOBA Xterm here. Like I said, I love it because of its versatility and just its ability to have these VNC commands, which we need to see this Windows PC. So let's go ahead and pull up each of these, the access switch and the distro switch. Hopefully they're almost booted up. But if not, like I said, we're going to work through each of these things. But let's go ahead and get logged into this PC01 on Eve NG. The default password is test123, and we've not changed that. Again, it's the image that we have here. Distro is up, access is up. All right, cool. So let's start with the distro switch here. We're going to keep the drawing here on the left side, and then we'll configure here on the right side. Let me minimize this actually. On the right side, this is a triangular design. It's really the same concept. The intent here is to just demonstrate or show once we get to the timers and we get to actually demonstrating what's going on here, we're just gonna get into this pre-configured environment and just demonstrate or show what it looks like there. And I'm gonna give you really my thoughts in a tidbit that I think in a virtual environment versus a physical switch by long ago, the back in my day kind of experience that I think is off here in this virtualized environment. But again, I digress. Let's get it. Distro switch 01, let's hit enable. We'll get into configure mode. And then here, straight off the bat, we'll do host name. We are calling this distro underscore switch 01. First thing that we do there. Gig 0001, let's configure those trunk links. So we'll do interface range gig 00 through 1. Switch port trunk encap tab .1q, and then we'll do switch port mode trunk there. And so on the distro side, we've got it set up going down on those two interfaces to our access. And then let's go ahead and exit out of here. We'll configure VLAN 10, and we'll name this VLAN 10. No space between those. We'll exit, and on this one we'll give it an IP. Let's do int VLAN. Actually, before I do that, because I know it's going to come up, let's do logging console alert. That way we won't get all those up down command. Let me see. Logging. Where are we at? Why is my login not working? Let's see. I'm typing login. I don't know what was going on there. Oh, no space, but looks like it. But we're all good there. So that way, when we do the up down or when the IP comes up, we won't see those alerts. And again, let's get back into interface VLAN 10. IP address, we'll say 10.10.10.1, the mask of /24 for this facetious network. So we've got our VLAN, our interface VLAN, our trunks. Let's do our spanning tree configurations. And if we do that, we'll see if we configure spanning tree for VLAN 10, we want this to be the root. We always want to set that, deterministically is probably not the right word, but we don't want there to be a chance for, even though it's a simple we want two switch design, we want to start getting or committing to our memory anytime we're designing or configuring it, just to get in the habits of it. So if we were to do question mark, we see that there is root and we configure this as root. But if we do priority, and let's type something totally wrong, 11111, if we were to hit enter, we see here that we need to make the priority an increment of 4096. And so to make this a root via that, as opposed to just pressing a root, we'll type 0. But because we have VLAN 1 on this switch as well, let's go ahead and make this the root for VLAN 1 as well. And let's, although by default the spanning tree mode is PVST, PVST. Bad typer today. Get rid of 2 trees. We'll just go ahead and type it to confirm it. So on our distro switch 0001 downstream VLANs, interface VLAN, host name, what else we got? Span. We're all set. Just doing a mental check while looking at this drawing here. So let's go ahead and get on over to our access switch. We'll hit enable, conf T. We'll do host name. What's our tab say? Access _ switch 01. We'll do the same regarding what was it? Logging console alert. And then we'll do VLAN 10 name, VLAN 10. We don't really need an IP address, an interface VLAN or logical address here. So let's skip that and go straight to our int range gig 00 through 1. And we'll do switch port, trunk, ncap.1q, switch port mode, trunk. And downstream there we see gig 02. So we'll do int gig 02. We'll do switch port mode access, switch port access VLAN 10. And then our spanning tree, I think, is all we got left. Again, although it's, if the other one's the root and this is only 2 switches, we technically don't need to configure this secondary, but we want to establish these good habits early. So we'll do spanning tree, VLAN 1, 10, priority 4096. All right. So now let's go ahead and talk a little bit about spanning tree. And before I do that, let's go ahead and configure PC 01. And then we'll get back to spanning tree. That way we've taken care of all of our configurations first. And so what we're going to do here, we're just going to statically assign an IP address. The DNS server doesn't really matter. We're not touching the internet yet. In a future video, we'll bridge this. We'll drop a cloud network there and we'll bridge this to our home network so that it can have, or these devices can have access to the internet. Oh, so we already got this one, or it came with this. But that's not our IP. Maybe that's the default. So let's, although the 10 is right, so maybe save time, even if it's a second, we'll type that. This will be a /24. Our gateway will be 10.10.10.1, which is that logical address of the distro switch. Again, we don't too much care about DNS. So we'll save this one here. And while that's closing, let's go ahead and bring up a command prompt. We'll type cmd. All right, there we go. We'll bump up the specs on these devices next time because this one's a bit slow. And we've got some memory on our hypervisor. This EvenG instance is hosted on ESXi. All right, so this command prompt should be coming up. And before we just discuss the default timers, the default setup, and really what we just configured and demonstrate and discuss it there, we'll just ensure that we can, let me get on over here. We can ping across. Let's see. First ping should be no go. Actually, okay. Tell you what this is without even looking. I think we didn't no shut the logical interface here. Do show IP int brief. Yeah. So we'll do int VLAN 10 no shut. We'll go back here. We didn't do continuous ping. Yeah, there we go. All right, so our setup is good to go. So going back to, let's hang around in our access switch. If we do show spanning tree VLAN 10, let's do summary first. And we see here that we've got 1 blocking and then 2 forwarding. And so if I was to draw this out, like we've got our access switch here in the middle, and the 2 that are forwarding are basically going northbound, are up to the distro switch here towards the root. Downstream, like the blocking is more speaking of the BPDUs, or those BPD updates that go to keep the topography from a spanning tree perspective across the switches. And so we'll see these 2 ports are the one that will transition depending if we're PVST or Rapid PVST between listening, learning. So that's what we got there. Now, if we go up again and we do detail, this is where we see kind of for this VLAN, the information. If you had 1020 configured, if you needed to start drawing on paper, when I first started learning these circles, these lines, these values, if you got a spanning tree problem, this most likely, or you go to specific interfaces and see this output, this is where you start looking at like the cost to determine is STP making like an incorrect decision, especially if you inherit a network that's had problems and no one's tuned it correctly, or there's one switch that's configured wrong. You kind of have to start getting ready to listen and learn these. But for our simple topography there, what we see here is on gig 00 and gig 01, that 00 is the root forwarding. So it's forwarding traffic, those BPDUs and traffic up towards the distro switch. And gig 01 is the alternate, but it's blocking. Now you may ask, why is that? Like what made it pick 00 versus 01 when it came up? In the Cisco world and so many different things, the lowest value, whether it's, you know, HSRP, whether it's the spanning tree, like if you don't set those priorities, which values the root, it's the lowest value of different attributes or settings. And we see here that the port identifier is .2 for the one that's blocking, and it's .1 for the root forwarding, because of course the MAC address is going to be the same for both ports on the switch. So that's really out the gate why that was there, or that decision was made. But that means, if you remember, we're going to need to make a transition state. We're going to need to take down gig 00. We'll take down 02, 01 to show you that there's not going to be a change, because that's not the port that's forward. And that's probably what we need to do first to hammer that one home. And then on port gig 02, you don't see root in there or alternate. It's designated forwarding, again, not towards the distro. All right, so that's our setup there. And like we said, to get ready, just by default, let's take a look. Let's keep a continuous ping from our PC. And like we said, we'll shut down the wrong port and see if there's any changes there. There's a command we want to do. Let's prep. We want to start our output here at this line, backbone fast. So what we'll do is we'll do summary, and we'll begin at back. We'll just type backbone. And when we get out, it just won't show those higher two. So let's go to conft. Let's go to int gig 01. Let's do a shut and a no shut. Control Z. Let's see if there were any changes there. We see 2 are forwarding. Now 1 is in blocking. 1 in blocking. So did we lose any? Nah. And again, like we said, the reason is because that's not where, from the access switch, that's not where the BPDUs or the topography changes from a spanning tree view are going. It's going out on gig 00. So what we really need to do is shut that port down and bring it up. And that's where the state that there's an issue in spanning tree, we need to basically go towards that alternate port. Actually, let's not even bring gig 00 up. I didn't think about that. So we'll go to conft, we'll go to int gig 00, and let's just shut that port down. Then we'll control Z to come back out. And now let's take a look and see what's happening. Oh, we see a listening. We see something going to this listening. And here we see our timeouts. So these are the transitions that now it's going to learning. And once it comes up and starts forwarding, we'll quickly kind of explain what that really means. Host is unreachable. Actually, let's see if I can hurry up. Let's see. I was too slow, but I'll explain this to you here. All right, it should be there. All right, so our pings are across because if we press up twice real quick, we see that now it's back to forwarding. But while it's transitioning across these different states, in the listening phase, that's where the BPDUs are always there. But of course, it's detected that there's a change in the topography. And so this is where no MAC addresses are being learned, but we need to determine kind of what the state of our STP environment is, what our routes, our alternate, etc., so that we don't cause a loop. And so spanning trees taking the time really in the back end to determine or reconverge that best path. Once it transitions into that learning state, then it kind of knows which ports and which paths to take. And in those BPDUs or in those updates, that's what it's telling it switches. It's flooding those things out. And this is where the MAC address table will start to populate. And then, of course, forwarding, that's where everything is being forwarded there. So we saw that, not from a packet perspective, we control C because folks think those are like every second, but it's really not. But we actively watch with our show commands the transitioning to listening and learning there. So let's go ahead and do the same thing, but let's change our environment on both our access and distro switch. Let's go to conft and we'll do a spanning tree mode. Now let's do rapid PVST and we'll copy this. So we could type it and we'll type that one in there. And now if we come back and we do show spanning tree summary, or actually not summary, but well, we do see it here. Switches in rapid PVST mode, but also detail, we'll see that it's doing that as well. So again, we got the changes percolating through because we've changed the state, but let's make sure we get back to, let me control C here, a stable environment, to forwarding, to active. And now from the access switch, because I don't think we ever no shut it, the port, but let's go to int gig 00 and let's do a no shut. And let's wait for this to get back into the proper state, and then we'll just see which port is let's see, show brief RQ. There we go, learning, skip listening. All right, they're both in forwarding. So with detail, let's just, what we're trying to determine here is port 1 will become or resume the forwarding towards the root. All right, so we got 0, 0, and 0, 1, and yes, we're back to our original state of gig 0, 0. So not to take away, but once you start studying HSRP, GLBP, VRP, etc., there's that notion of presumption, to where if, you know, port comes back up, should it take over? We see here we don't have to in STP configure any of that. It goes back to once all ports are available to be forwarded across, or not to say elected, but kind of an elected to know which one, calculated, I guess. It'll go back to using those attributes. So long story short, we now have changed from PVST to Rapid PVST in our topography. And so now we just need to really do the same thing. So we'll go back to PC here. We'll hit enter. We'll start our pings. And then from access, we'll go to configure mode, int gig 00, shut, Control Z quickly. And let's see. All right, there we go. And we're gonna, what we anticipate is skipping the listening phase. That's really what we are expecting to see here. There we go. So we went straight from blocking or not seeing there to learning. We didn't go into that listening phase. So we skip that phase, and we should be in forwarding right now. And so the pings should be going through. All right, so really that's the crux of it. Again, if you had a bigger environment and the diameter was, you know, exceedingly large, although at the macro level, if you configure it, I won't say level or phases, but, you know, a core, a true core distro and access, you typically, well, I won't say typically, because especially downrange, sometimes we had an access switch that sat behind another access switch, like a small shack with one person working in there, or a switch that's nailed to the wall outside. We didn't run fiber cable straight to the ITN to the distro switch. It trunked off of another access switch. So that's what I mean by diameter. Depending on how many hops you got to get to the core, these topography changes or updates from the BPDUs can be, you know, pretty exceeding. But let's say we wanted to tune. Let's do that before we take a look or explain the right side, which we won't spend too much time in. In the distro, if we go to conf T, let's do, I think it's spanning tree, VLAN 10, 4 time. Like, what if we made this 4, and then we did this same thing on the access switch? All right. So on our access switch, let's do int gig 00. Actually, do I have a notepad ready? This way I can do it a little bit quicker. All right, so let's bring this over. This way we don't have to wait twice. So this is seemingly becoming a little bit, might take more time. So we're in int gig 00, we'll do no shut, int gig 01, we'll shut. So there won't be any path until gig 00 resumes that. I guess I need enter after. All right, so let's do that. All right, so now we'll take a look and see, is it any quicker? And hopefully we kept those pings going. Wow. Oh, pinging already. Well, that quick timer. Well, try to get ahead of myself. We'll let this reconverge, which it already is, because it's so quick. And we'll do it again. We'll take gig 00 down so that you can see. But changing, this is the conf T int gig 00. We'll shut that down. Control Z. Let's try to be quick and see how long it stays in learning. Just pressing up enter about every second. All right. Oh, forgot. I'm so slow. We shut down gig 02. I was like I said, we're working through all these problems. So here, let's do this. We'll do conf t int range gig 00 through 1, no shut. Put a G in front of it. Yeah. All right. No shut. We'll let them both come up. All right. All right. Both forwarding. I don't know what this looks like on this end. I don't know. It's like, all right, cool. So we're back to, well, let's not assume. Let's go. Let's make sure. Let's just type show spanning tree detail. Let's make sure gig 00 is forwarding before we take it down. We see that it is root forwarding. Q conf t int gig 00. We'll shut that down. We'll control Z. Press enter a few times. And we did see, if you were looking kind of closely, the learning, it's already done. And it's because we tuned the timer. So we went from kind of seeing 8-ish timeout, combination of timeouts and unreachables to just 2. So not just relying on the default timers, but if you know your environment, which you should as a network administrator, engineer, whatever title you're in, but you can properly tune it, your environment as well, to basically decrease that convergence time there. So that's another pretty sweet note here. Really nothing here to truthfully show. Let's go to switch 4, 5, and 6. Let's just bring up 6 in this Windows. This is just to show that I heard someone say that in a triangular type environment that you should, you should, you should not experience as much time by default. I'm not, no tuners there. So let's open PC2. I think that's switch 6. Yeah. Switch 6. And we're going to do the same. All right. So let's hit enter. Pinging 10.10.10.01. Like I said, this one's already configured, this environment. Take a look. And I appreciate all of y'all that are hanging around. Definitely feel free to drop a comment. If you got a question about anything or want to see a certain video, show run pipe begin. Let's just see. So we're in Rapid PVST, gig 00 and 01, just trunk again, or 01 and 02 trunk. 00 should be the access switch, goes down to that PC. So nothing special or unique here. So if we go same show spanning tree, actually we'll do VLAN 10 in detail. We'll see that for VLAN 10, gig 01 is root forwarding on this side and 02 is alternate. So we'll do the same thing. We'll ping, get our pings going. They're successful. And then we'll shut down this root forwarding, which is gig 01, conf t int gig 01 shut. We'll come back to here. We'll watch, hopefully in buffer, maybe not. Oh, we got to type VLAN 10 summary begin backbone, and it's probably already there. Nope. All right, we caught it. So transition straight to learning. But again, this is default timers. It's not that changing the forward delay from the default of, I think it's 15 to, I think we changed it to 4 or 5. There it goes. So we should see the pings successful now. So still, like I said, in a triangular type design, in a virtualized environment, we don't really see any significant improvement there. And in MST, we should probably really see similar results. If anyone, before you ask the question, MST, multiple spanning tree, what it does is it creates, I won't say pools of different VLANs, but it decreases kind of the load on the CPU or performance. So instead of, like if we go, let's go back to here, let's just do show spanning tree. And there, control, I needed to do show spanning tree. Let's hit this. Actually, we don't have but two, but in an environment where there's like 100 or hundreds of VLANs configured, like the root switch needs to, like every 2 seconds by default, send updates to keep that topography or view of really the architecture from a spanning tree perspective in line among all the switches. It's got to send those updates for every VLAN. And so in MST, what it does is you create kind of like these regions or these instances. If you put half the VLANs in one instance, half the in the other, then it just needs to send the updates to those two pools or groups instead of per VLAN. So it reduces the load really from a update topography type, which, like I said, is processed by the CPU there. So like I said, this is really the crux of the day, to get back into the lab, to just get back in the mode. I need to get, like I said, I don't do layer 2 too much, working in an AWS environment where AWS takes care of the layer 2 stuff behind the scenes. But we've got these different images to kind of do future videos, especially on the CCIE security side. We're going to focus on CCNA level studies for the time being. I see are sparking interest from talking to folks out there that there's still a lot that are coming into the game. People try to say network engineers dead. I don't think I won't say ever, but in my lifetime, hopefully won't die. We do know that AI is being used in almost every industry, so I get the concern. And I'm not going to say that it won't supplant, in my opinion, at least for the short term, certain junior network administrator positions, which is very unfortunate, because you got to see those problems and get that stick time to really become a better or more seasoned engineer. I see that being the biggest short-term detriment. But I think we still need the professionals in our environment for a while being subjective. But like I said, I digress. So this is the purpose of today's video, was to demonstrate not just STP, the configurations that are needed, but to really show and demonstrate it going through those different phases, to see the importance of it, to see how we can tune the priority and what that has, to see if you type it wrong. Like I said, on the test, Cisco it's more of a custom based image. Like you're not able to do question mark on a lot of things like that. So you might not be able to type the wrong value and get those if you're not good with math, or if you get flummoxed on a test. But like I said, just train as you would test and as you would work. And it's the stick time, the increased things, where even if someone gave you this template or configurations, if you pause a video or if you lab along it, so that the concepts start sticking. When you get to your higher level, like CCIE certs, it's so things and configs become muscle memory. You might have noticed me typing like SW, switchport mode, MOTR for trunk, the shorthand. And that's because even though 8 hours seems like a long time, it goes by. And so if you learn the shorthand tricks with configurations, it might spare you an extra 5 or 10 minutes that you might need to double check at the end. So that's the reason for those. But thank you all so much. And for the few that truly watch this entire video, it always means a lot. A lot of us content creators, we put stick time into this. And like I said, it's just kind of wanting to see a little bit of appreciation. Not myself, like I said, I'm not trying to put it out there, but just a nod to try to support some of those creators and some of the smaller channels, and not to take anything away from the bigger channels out there. Much love and appreciation there. But if you see my boy Celestio here, are certified curls. Both of these are amazing content creators going through their own challenges and journey. latest up, Celestio's got this podcast. He might be up to 9 or 10, maybe 11 or 12 guests. YouTube shorts come that shows his 30 to hour long videos with CCIE. So if you want to get in the mind of those from around the world, he's in Portugal. He's an amazing content creator, amazing human being. Got the chance to speak with him months ago. We keep in contact on LinkedIn. And then, Certified Curls, Alicia doing her thing there. The journey and the aspiration a few years ago to become a network security engineer. And she finally reached that goal. And she did a lot of videos 3-4 years ago, especially during COVID, where switches, routers, and different things were getting mailed to her house. She was configuring them, troubleshooting them, mailing them back out to customers. And like I said, she finally felt like 2 years ago, got that first firewall or that network security engineer job. And so she takes you through her journey, her day in the life, her car, just different things there. So just want to support and big up these two amazing content creators and just so many others out there. But like I said, I'm getting long-winded now, and let me go ahead and call it a day. But until next time, stay safe, take care of yourselves. Peace.